of the days, the flight takes more than an hour. On 3% of the days, the flight lasts 75 minutes or more. Use this information to determine the mean and standard deviation. And like, I know we have to use table A, I just don't.
Yeah, I'm not sure that
Right.
that's actually a normal distribution problem, but is there, and I mean, I heard most of what you said, but is there any way to get a picture over of that stuff? That really is, it's tough for me to write all that down and make sure I understand the full context of what you're giving me.
I'm emailing that question. Okay, it's sending.
Okay, yeah, I see you. You sent something over. That's awesome. Okay, yeah, so we can look at something like this. I mean, this is not a normal distribution problem. But we can look at this. Although it does say, okay, I'm sorry, it does say it is according to a normal distribution with unknown mean and standard deviation. So a problem like this, usually when they tell you information like this, it's almost like they're creating this what's called a probability chart. What do you know what book this comes from?
It's called, it just says the practice of statistics.
Okay.
Like Starnes, Yates, Moore for AP. For the practice of statistics for AP 4th edition.
Okay, so this, yeah, you're right. This is an empirical rule question. So we'll try to, let me try to answer this one as best I can. Let me grab this empirical chart.
Okay.
So you've probably seen this. Oops, it didn't grab it. All right, let me do a different snip. Okay. So you've probably seen this in your classroom. Is that right? Roughly. So
yeah,
what they're trying to tell you in this problem, and this is kind of an awkward problem to start with because it's not even a standard problem. It's saying 15% of the flights take more than an hour. So you're trying to figure out where is about 15% in the curve. So if you look at everything to the right of this line, okay, everything to the right of this line, it's actually 16%, but we'll say it's about 15%. Okay, so we know that 60 60 minutes is like this one standard deviation from the mean.
Mm-hmm.
So we know that the mean plus one standard deviation is 60 minutes.
Mm-hmm.
And if we wanted to use variables, you probably saw this in class, they probably say x plus sigma equals 60.
Mm-hmm.
Now, 3% of the flights take 75 minutes or more. So where is 3%? Well, 3% is about 2 standard deviations away. I mean, it's 2.5%, which we're kind of estimating to 3%.
Mm-hmm.
So we're saying that the mean plus 2 standard deviations is 75. And this is a system of equations.
Mm-hmm.
Okay. And from your previous courses, you're supposed to be the expert at how to solve systems of equations. So any idea how to proceed from here?
Um, you can. Oh, it's been a long time.
Yes. So let me move this equation down here. And if you subtract the second equation from the first, you have x minus x, that's 0. 2 sigma minus sigma, that's sigma. 75 minus 60, that's 15.
Oh wow, that makes so much more sense.
Okay. Now, whichever, you can choose either equation, but let's use that first one. X plus sigma equals 60. Sigma is 15, so x plus 15 equals 60.
Okay.
Subtract 16 from both, or 15 from both sides, so x is 45. That's your mean, and that's your standard deviation.
Okay.
Okay, but as I mentioned, like this is a very sophisticated problem. And you gave me problem 61. I mean, that's a very difficult problem here. You have to know the empirical rule. And my question to you is, how well do you know this? And it's okay
Oh
if you
yeah,
don't.
it's like the one thing that I actually do know.
Okay.
It's like
So you have to know,
68.
yeah, and more than the 68 and the 95s, you got to be able to chunk it out into these blocks.
Yeah, because it's just like divided by 2.
Right. And so the only thing that I think could throw you off in a problem like this is kind of this estimation that 16% is about 15% and 2.5% is about 3%. That's probably the only thing that would throw you off. But you're right. This is a normal distribution problem. I mean, it says that, but we're using the given information to determine the mean and the standard deviation.
Okay. Okay. I think
Now,
I was confused. Okay, so like in class today, we went over this problem and I was just beyond lost because they used the like the table to find the z-score for
so yeah, so that is true. Okay, now let's do it the completely official way. Okay, let's do it the completely official way, because that's, yeah, I mean, that's kind of what we're saying. So the 15% means that the area in the right tail, the right tail is 0.15. Now, the way your table works in the back of your book, it doesn't work right tail. You have to realize that the left tail is 0.85. And so you're looking that up in the table.
Okay.
Now, we can go through how to do that. Let me pull up a table.
Yeah, I don't know how to read this table.
Yeah, it's not intuitive. And we're so used to doing things with, and so that's why I really wanted your table. So is there any way to get a copy of your table over? Because there's actually, I realized there's actually a couple of variations on the table.
Yes.
Yeah, if you could email that over, that would really help. Even if I know it might take a moment to get the pages, but this will be the best way for me to help you.
I'll pull it up. Yeah, I just don't know how to read this table, and I don't know how to apply it to figure out things. I actually need to print this table for tomorrow's test. Okay, that's it.
All right, great. I do see that's in here. Yeah, this is very helpful here. Okay, so we want to go, yeah, there we go. All right. Okay, so let me see if I can snip this one. Okay, so we're looking at, you're looking in the sort of the, I don't know how to describe it, the part of the table, like the interior of the table, not the top and the bottom. So let me say it differently. So the things that I'm boxing in, these are areas,
Okay.
or you can think of them as percents. Okay.
Mhm.
So you're looking for the closest to 0.85 in this table. Okay, so let's see if I can find that here.
0.85.
So I feel like it's kind of right between these two.
Mm-hmm.
Okay, between those two numbers.
Okay.
So the one on the left here is 1.03.
Mm-hmm.
And the one on the right here is 1.04. Now, what some students do is they estimate, but the truth is it doesn't really matter because you're going to get close enough. But we'll call it 1.035.
Okay.
That's right in the middle. Okay, so that's your Z. That's your Z. So the Z's are kind of along the column and the row.
Okay.
All right. So what does that mean? So and that's where this is, that's why I used 1. I mean, I was pretty close with that.
Mm-hmm.
But you have this formula. You have Z equals X minus mu over sigma.
Mm-hmm.
Okay, you've seen that before?
Yeah.
So this is a Z value we just found. So we're saying 1.035 equals X minus mu over sigma. And then you want to rearrange this equation. So you're going to multiply both sides by sigma. So 1.035 sigma equals X minus mu.
Mm-hmm.
And that's where we can move some things around if we need to. So yeah, and that's where this is kind of awkward because we do have the X value. So the X value was 60 minutes.
Mm-hmm.
Okay, so we actually can throw that in. 1.035 sigma equals 60 minus mu.
The other one.
Okay. Yeah. Sorry, it's such a late lesson. I usually got earlier times. Just we'll just have to sync up better for the future.
Yeah.
And I'll talk to your mom. I'll let her know, like doing one lesson isn't going to solve the problems here, but
Yeah.
well, I'll do my best to try to get you prepared for tomorrow. So we have to do the same thing now for the other one. So if we go back to this picture, the first one was 0.15, okay, in the right tail. And if I go all the way back to the problem, now we need 0.03 in the right tail. So it's basically the same thing again. You got this normal curve, you've got 0.03, 0.97. So that's what I was trying to tell you is you never look for right tail. You can only look for left tail. And so this is where you need the rest of the table to be able to answer that. So let me snip this in. We'll, again, kind of work together to answer this. So you're looking for an area of 0.97. So you're looking in the interior of this table. That's the word I was looking for, the interior. And you're looking for 0.97. And actually none of these are there. So let me go and grab the other half of the other table.
1.80.
Yeah, so let me actually grab this.
It's literally 0.01 off of 0.97.
So we're looking for 0.97. I think you said it's right there. Like that one's pretty good.
Mm-hmm.
And then so it's 1.8, and then I believe it's 8 is the column that it's under if you slide your finger up, or maybe you're doing this digitally, but that's 1.88. That's your z-score.
Mm-hmm.
So you go z equals x minus mu over sigma, and 1.88 is your z, x minus mu over sigma. You clear the sigma again, so you get 1.88 sigma, and this time x is 75 minutes late. You can think of x as like your real value.
75 minus mu.
Yeah, and then
a system of equations.
Yes, and this one's more sophisticated than the one that I gave you. The answers actually won't be that far off. So how do you go about solving this? You can still subtract though. That actually will still work here.
How do you do it? The like other way where you get like, because in the way.
So probably what you guys did in class is you solve both of these for mu.
Yeah.
And so by doing that, so to solve for mu, you're going to add mu to the other side and subtract. So mu equals 75 minus 1.88 sigma. And then same thing here, you're going to add mu and subtract. So mu equals 60 minus 1.035 sigma.
Then they equal each other. And
yes, exactly.
Okay.
And if you don't like mu and sigma and x, I mean, you can use different letters, but you are going to use them throughout the whole course. So there is value in right now trying to get comfortable with them. Subtract 60 from both sides, add 1.88 sigma. So on the left, you get 15. On the right, you get, that's why you got a calculator, because you're going to have some
0.84 sigma. I think.
Yeah, I mean, it depends. It depends if you went out to another decimal place or not. But yeah, and then you divide by 0.84 or 845. And you should get really close to what we had in the previous problem. You get sigma is 17.75 roughly. And again, I'm going to send you a PDF of the notes at the end. So if you don't get all this down, you can look at it later. And then you go back and you just pick an equation. Like, actually, let's pick just pick this top one here, and you use it to find the value of mu. So mu equals 75 minus 1.88, 17.75. And you get mu is about 41.63. Now units are important. I didn't specify that in the first version of this question, but you do want to include your units. It's minutes. The sigma and the mu always have the same units.
Okay, I actually get that.
Good. So is there another question that you would like us to go over? Even like a 62? Well, there's a little more to 62, but something else that we could look at together.
To the data into 63 was fine. Then just did the Histogram 1 var stat calc 1 var shapes and spread. Okay, that's fine. Can we do? That's just reading the table. Can we do one for like 47?
Yeah,
Okay.
just waiting for this email to come in. And for future lessons, you can always send this stuff ahead of time. You can send me as many emails as you want. Whatever you want to do to get them to me.
Okay.
Be the best for you. So come on, inbox.
Uh-huh.
How's the rest of your classes going?
It's not bad. Government is difficult. But other than that, it's really not that bad.
Have you chosen a school for college?
I'm committed to BYU to play softball there.
Oh, nice. Just waiting on this to come through. Did you get a chance to go and visit the campus?
Yes, I
Awesome.
have been there and I absolutely loved it.
Excellent. Yeah. So this is where I was going to have us start actually with just sort of, table practice problems. And so let's do that here. All right, so let's look at, we're going to just go one by one here. So A says that Z is less than 2.85. So you're going to draw a lot of normal curves in this class. You want to get drawing them as best you can to start out. And right down the middle is 0. Okay, so 2.85 is pretty close to the end here. So, and because it says less than, you want left tail. And what that means is everything to the left, all this stuff. And I think it's good to actually shade it all in and label it right there, 2.85. And hopefully you've been doing that in class.
Okay.
Okay.
Yeah.
Now this, you're going to like this better because when you're given a Z value, you go right to the table where that Z value along the left edge. So I'll show you that here. Let me slide this in.
Oh, sorry.
Bless you.
Thank you.
Okay, now, so the Z is right here. So you want Z of 2.85. So you go down Z, there's 2.8, and you want 8.5. So see where these intersect?
Yes.
You want that value right there.
Okay.
And that's your answer.
2.85 shade in the red.
And so what we're saying the area left of 2.85, the area under the curve
is that.
Is 0.9978, the area under the curve. That's what we're saying.
Oh. Okay.
All right, now let's do, I'm gonna have to snip this again. So now we're gonna do part B.
Okay.
Part B, again, you're gonna draw a normal curve. You're gonna draw a lot of these. And you draw 2.85. So 2.85 is right there. There's 2.85. Sometimes it's good to put 0 in just as kind of a, now it wants greater than. That means it wants right tail or right of it. So right of it's right there. Okay. Now here's the major problem. Your table only gives left tail. Only gives left tail. So you have to do a calculation. And you know the left tail already because you did that in part A. But let's just say you didn't know that. You would say, I'm going to find 1 minus Z less than 2.85. Because the whole area in the curve, the whole area in this curve under the curve is 1. So if you want right of this number, you find left of it and subtract it from 1.
Okay.
So the number we just found, 0.99, what did we say? 9978. we're subtracting that from 1.
Mhm.
And that's 0.0022. There's no way to get this number from the table that's reasonable. You really want to
The
always do these
calculation.
1 minus. Yes.
Okay.
Okay, so here's what you have to remember from this problem. Whenever you're doing right tail, you're going to do 1 minus left tail.
Mhm.
You're never going to do anything other than that. But if it's less than, like in part A, you just go read the table.
Mhm.
So what kind of questions do you think your teacher's going to give you on the test? Left
I
to,
genuinely have absolutely no idea what it's going to be on the
okay,
test.
so it's not going to be A. A is too easy. They're going to give you
Okay.
right. They're going to give you right tail most likely because
Mhm.
you know A, you just go look it up in the table. That's that they think, oh, that's very straightforward.
Mhm.
Right tail, you're going to go look it up and then subtract it from 1.
Mhm.
All right, so this will make more sense when we do part C. So let's do part C now.
6, I have to do the drawing. How do you know where like the 2.85 and like the 1.6 is?
Okay, yeah, so I think that's a really good question. Let me answer that and then we'll come back to this question. So on a normal curve,
Mhm.
again, we're drawing a ton of these normal curves. Okay. Here's 0. Z is along this axis here. So 1 standard deviation away literally means 1.
Mhm.
2 standard deviations away literally means 2. 3 standard deviations away is 3.
Oh.
And by symmetry,
What?
and I think you're going to find that this class isn't as difficult as maybe it first appeared. By symmetry, if you go left 1, 2, and 3.
This would have been really nice to know while I was learning this. But they just never said anything about this. That makes so much more sense. Wow. Wow. That's why I had no idea what was going on.
So this is how you estimate where it is. And your teacher will probably give you a problem where you need to draw the curve. And like I did in the previous problem, I'll come back to that. Your 2.85 needs to be roughly in the right place, meaning like it's not here near 0, it's closer to the tail.
Okay.
All right, so now let's go back to your problem.
Mhm.
We want Z greater than minus 1.66. So minus 1.66, I don't know, roughly, I'm going to put it right about there. That's minus 1.66 roughly.
Okay.
Okay, that's reasonable. Not reasonable will be over here. Not reasonable is over here. Now we want greater than. That means we want everything to the right of it.
Everything.
We want right tail.
Okay.
But I already told you
Right
this.
thing only tells us left.
Yes, so you don't. So we're going to do 1 minus left. So you're going to go to your table, and your table is going to give you, I'm going to show you this in red. Your table is going to give you this value right here and from the table.
Okay.
Okay, so I want you to try looking that up in the table for me and tell me what you come up with.
Wait. What? Okay. Wait, if it's negative
Go to page 1 of your table.
2 point. I need to see if I messed something up. 2.8. I'm
Okay,
confused.
let me.
Wait.
I'm looking at the first page that you sent me.
Mm-hmm.
I gotta go past this for it.
Other tables.
So this is what I'm looking at. You're looking for on the Z minus 1.6.
Oh. Minus 1.6.
And then 6.
0.485.
Yes. So here's what that means. Let's go back to our picture. That means that in this area over here on the left is 0.0485.
But we have to do 1 minus
We have to do 1
that
minus
to
that
get the
because we
other
want greater
side.
than, yes.
0.515.
I'm sorry, you're doing 1 minus 0.0485, right? Is that what I'm
Yeah.
hearing? Okay. Good.
Yes.
Okay, so super critical, right? You know, we did 2 right tail problems, 1 left tail problem. Is the right tail clear how to do?
Yeah, you do 1
Okay.
minus. Yeah.
Okay. All right, so now we're gonna do part D. Actually, I'm gonna do that because we're gonna grab it here.
9, 5,
Okay, so part D here.
Oh,
So
Lord.
this is the between case.
Mm-hmm.
Okay. Okay, so between. So we gotta find these two z-scores. So here's minus 1.66.
Mm-hmm.
Okay, and here's 2.85. So we want the area between them.
2.85, 1.66, 2. Negative 1.6. We need. Okay.
Now, this is not a trick question that I'm about to ask you. Does the table give you between values? Or let me go. So since you didn't answer that quickly, does the table give you left areas?
Yeah.
Does it give you anything else?
Not without an
No.
equation.
Right. So there's no way to do this directly is what I'm trying to show you. Like because whenever you get a between, you end up having to do the following. You have to do, and I'm going to draw 2 pictures here so you can see this. Okay. So the first thing you do is you find the area left of 2.85. So you find all of this.
9978.
Yes. And then you find the area, let me draw it here, left of minus 1.66. Okay. So you just told me that. You said it was 0.9978 and do you have that number? 0.0485?
0.0485.
Yes. And you subtract them.
Less.
And the reason you subtract is because there's an overlap. So you're subtracting out this overlap in this area over here. This is all overlap.
0.0. 0.9978 minus 0.0485. So I subtract that from that and it gets rid of that. So I have the middle value. Wow. And so why was this never taught to, like, what?
Well, I'm gonna pat myself on the back here. I like doing this and I want to help you. So I hope you'll schedule more lessons and we can get you, to where you're saying, this isn't all that hard.
Yes, I definitely will, because this made no sense until right now.
It is kind of a foreign language, and you probably will take it again in college. Even if you get credit, you may find that your department wants you to take their stats class, whatever it is. So you may see it again. And if you go to graduate school, you'll see it again.
Yay.
Yeah.
Yay.
All right. Any questions on that? And you do need to know all 3, types of problems. We can just summarize here. We can say Z less than means left tail. And that's where you go right to the table. You're just really happy. That's the best case. You will not get that on the test. Z greater than is right tail. Okay. And you do 1 minus the table value. Okay. And then the last one is the between case. you got these betweens here. So this is between or in the middle, and you do left minus left, which means table minus table. Okay, and just make sure those are super clear if you have any time between now and your, your test tomorrow to look at those.
Mm-hmm. Left minus left. Yeah. Yeah. Table minus.
Do you want us to do problem 48, or do you want to send me another problem for us to look at? We've got about 10 minutes left in the lesson.
Can we do? Can we do one of these? Okay, so there's some that are like working backwards, where it's like still with the
Yes.
table. Do you want me to send you that?
Yes, yes.
Okay. And then I feel like the rest of this, I'll be able to learn, like, figure out by knowing how to do the table. I just didn't know how to do it at all. Okay.
There it is. I see you sent something over. All right. I see. Yeah. So we'll look at 51. The word questions or story questions, they're all kind of variations on this.
Mm-hmm.
So
Okay.
let's
Use the calculator or the normal curve.
okay, so here's the, let's talk about the 10th. Let's talk about percentiles.
Mm-hmm.
Okay, so right in the middle is the
It's
50th 50th percentile. The
Mhm.
100th is over here. So obviously 10th is
over
here.
there. Yeah.
Okay. Now percentiles, you want to think of those as areas. So the 10th percentile means an area of 0.10. So whenever you see the word percentile, think area, and you convert it right to the decimal 0.1. And that's where you go to your table.
Okay.
And you're looking in the interior of the table for 0.1.
Let me pull up my table. 0.1.
Yeah, and so let me snip the table in so we can also kind of look at it together here. So you're looking in the interior of the table, not the z value. So you're looking for a number that's really close to 0.1.
Negative 2.33.
Yeah, I like that. So that's the answer to part A.
Oh, that makes a lot of sense.
Yeah. There really are two types of questions, backwards and forwards in this. You're either given the z, okay, and that's easier. You're either given a z, like we did in the first problems, to find the area, z to find the area, or you're given the area to find z. That's it.
Okay. 34% or greater than z.
Okay, so let me draw it again. And you've seen how I've drawn every single one of these with a normal curve. I would strongly recommend doing that for, for tests and quizzes, just to make sure you got it. Percent means it's an area. So they're saying 0.34. So we know that about half is above here, or half is fully above there here. So we're saying it's kind of like, well, that's actually not very good. Let me that. So it's kind of like all the area over here. This area is 0.34. Okay, but it's in the right tail.
So I have to do the other way around.
You need the 0.66, the left tail.
0.66 for my table.
Okay, so you're going to go to your table and look for 0.66 now in the interior of the table.
negative 1 it's in between like 1.5, negative 1.5 and
No. You're looking in the interior. You're
wait.
looking in the interior of the table.
0.66.
Yes. So the
Oh,
interior of the
not
table.
okay. I was looking at 0.06.
And that's the common mistake is, either looking at the wrong number or something like that. Let me snip this in here. So do you see 0.66 somewhere in the interior?
Yeah, like 0.402 is
Yeah.
0.6628.
Yeah, I might go 0.415, but yeah, 0.41 or 0.42, those are perfect.
Okay.
That's it. That's your answer.
0.4. Well, what? That's literally the answer?
Yes. Because again, there's two questions you're given. They either give you a Z to find the area, or they give you an area to find the Z. And there's just, it doesn't sound complicated, but you get into a test and you can very easily look up 0.66 as a Z, but 0.66 is an area.
Mm-hmm.
And if you look up 0.66 as an area, you get a number that sounds reasonable, but it's not what they're looking for.
Yeah.
So you've got to be very clear. Am I given Z to find an area, or am I given an area to find Z? And that's how you go through this process. And there's no partial credit. I mean, it's like you either got it or you don't got it. I mean, unfortunately, that's, the other questions you'll have a chance at that, but pretty much right or wrong on all these.
Yeah.
Okay. We've got a little time left here. Are there any questions I can answer? Anything else that you're unsure about that maybe we can talk about here for the last couple of minutes?
There's, let me get my notes for the class. Okay, I can put that in my calculator. The 80th percentile. I think I get pretty much everything else. I just would get confused on the questions because I didn't understand the table at all.
Yeah, and I think you've got a better handle on the table between by what we've done. So if you have some time, I know it's late, but if you have some time, maybe in the morning or at lunch, you got some time to just review what we talked about and give yourself a better chance here. But my lessons are about 50 minutes. So kind of if we meet again, like I said, just get that stuff over to me as soon as possible, and we'll just charge right through this. And I'm happy to help with homework or test prep or whatever else you are needing.
Yeah. Okay. Thank you so much.
You're welcome. I appreciate you booking, and I'll see you next time.
Yes.
Have a great night. Bye now.
You too.